Our goal now is to take some of what we've learned and apply it to animate the motion of a pendulum. And so I'm going to give you some of the pieces and then leave a lot for you to figure out this time. Hopefully you're starting to get a little bit better at this. Just a second. There we go. So let's go to a screen share. All right. So this is going to be a starter code. You'll have all this stuff. And I just want to walk you through it a little bit. Some basic parameters here, some constants that we're going to use. Notice the angle is from the vertical in degrees. So we're probably going to need to do some work on that. Oh, I can see already here I converted the angle to radians so we could actually use it. Starting a clock and a sim speed, some standard parameters. Notice omega is a vector now. So the angular velocity is a vector. We aren't doing angular speed. The angular momentum is also a vector. And then here's a term d theta. That'll be a change in angle. And our rotation axis is right here. Let's scroll down and see what's next. So this is one piece of physics you'll have to figure out. I bet you can do that. Find a formula. And there's some drawings, so just some stuff to make things look pretty. Here's a vertical rod. Here we go. I rotated immediately after. That's a better idea than the last code that I did. So again, you can take a second to look at that. You've got the starter code. Notice I'm drawing a weight vector. That's pretty straightforward. I needed a scale factor just so the arrows weren't big. So again, the axis would normally be weight, but in this case, I multiplied it by the number 0.035 just so it fits on the screen. Notice there's an R vector from the pivot to the point the weight is applied, and I got lazy here, right? In this case, that's just the rod axis. I could have said, yeah, all kinds of things there, but, and I drew an arrow in this case. All right. So what do you need to do? This is basically what you need to do. I remember to increment the time already for you. So don't say I didn't give you anything. Come on. It's like Christmas here. All right. So first you need to calculate torque. So in the Euler-Cromer method, this is what's important. If we were doing this with forces, we'd first update force and then update momentum and then update position. That was the Euler-Cromer method in translational kinematics. Now what we want to do is we want to do torque. Torque is the rotational equivalent of force. L is the rotational equivalent of momentum. Remember, L here is not a length. It's the angular momentum vector. And now here, we have to be careful. We're going to eventually update theta. However, some of the same issues with rotation apply. So again, you could figure out the torque, then update the angular momentum, use that to get omega, right? They're related. So you could use that to get the angular velocity and then use that information to rotate the rod. But obviously you're going to have some kind of weird shape. I just called mine shape. Maybe it's a rod, maybe it's a circle or a cylinder or something, or a sphere. Everybody's going to have a different shape here. But so the idea is you're going to have some shape and you're going to use shape.rotate. So for me, I might use rod.rotate, right? But somebody else might use disc.rotate or whatever. But so put your shape right there. And then when we're doing that function, that uses a scalar angle. So you're going to have to think very carefully because our omega and alpha were vectors. Whoops, I misspelled that there, but that's okay. So think carefully there. And then don't forget, after you figure out that, you also have to update the arrows. Excuse me. Sorry about that. So that's what you got to be careful for. And let me just fix this while I see it so I don't forget. All right. And so when you get it running, I did actually make a code that ran just to give you an idea. And let me see if I could share this on the screen. Give me a second. I'm trying to bring it over here. The idea is you want a code that will do something like this. So what's nice about this is, again, we're using physics to figure out the animation rather than just making up a bunch of nonsense and making it look somewhat reasonable by guessing. We're trying to let physics dictate how things animate. Now, in addition to this, it would be pretty easy to put on plots. For example, you could plot theta versus time, and you could see, or maybe you could even go crazier. You could put in a section in the code where you get an integration of theta over time to get the total angular distance traveled. And then, of course, you could actually multiply that angular distance by any position on the rod to figure out the total distance traveled by any point on the rod. And so remember when we did the center of mass coding, if you're trying to do an integral, you don't just say, you could do something inside the code. I haven't thought it through, but I'll let you think it through. Like you could say total angle traveled. Let's say angular distance. To be clear, I mean distance, not displacement. So again, this is distance, not displacement. You could do a plus equals type statement and add up all the small amounts of angle traveled in each step, and I'll let you figure out how to finish that statement. But you could plot that versus time and you could then figure out distance versus time, all kinds of things. So we see that our codes are starting to get a bit more versatile. You could also put in some print statements after the code to get final values, or you could say, you could change the while statement, right? You could say while omega is positive or greater than or equal to 0, right? And so if that's the case, that would at least figure out for the first swing. So you could calculate information about the first swing by being creative with your while statement. Or you could say, I don't know, you could say while the angular acceleration is positive or non-zero or something. You know, you could change the while statement and learn about different points in the oscillation as well. So a quick way to do that is, again, change the while statement so that it stops at a certain point in the oscillation. And then afterwards, you could put out a print statement that says, hey, here's a value at this time. That should be, for example, you could get the period of a motion, right? So all kinds of things. You could even do that inside of here with an if statement as well. There's many creative ways. You could actually hopefully be a little bit creative and have a little bit of fun now because you maybe know a little bit. I hope you have fun with this one. I'm trying to make it fun and not be just do exactly what I do.